This to me seems reasonably responsive. I can deliver it as a single executable, packaging MUB up with the application, and the people who want to use it can use their preferred browser, i.e. Firefox, Safari, what have you, to access it. There are sufficiently complex and capable GUI components these days to enable you to do that kind of thing, to do this kind of form entry stuff at least. So that's one. I'm also playing around with this card thing. So what's being delivered here, this is actually using transclusion fairly heavily, but again, it's a what is it? It's a web service. It runs, in this case, on this machine, it's intended to run, it's intended to be sort of like a wiki-ish thing, and I'd like eventually, to have it running as, not to replace our wiki, but as a kind of a wiki. So, anyway, I think that's about it. Can't think of anything I've not covered. Oh, yes, there is one thing I haven't covered. RChan and TChan. When I was having some difficulty, and I still am, with making sure that all of the wiki's connections are being cleaned up properly, I needed to construct an object which had some state, which represented a channel, and I also had a problem with things dropping out and being reconstructed, things being channels, sorry, being disconnected and reconnected with the same name, because TCL uses a fairly, it densely packs the space of available channel names. So if you've got a socket 1 and it closes, the next socket that's going to open is socket 1 as well, which is a bit of a problem if you haven't got your resources, which are supposed to be tied to the socket, synchronized appropriately, which is easy to do on a mea culpa. So anyway, we moved to RChan, and that was very useful, and it works quite well. So anyway, that's about, have I got more time or not more time? No more time. Okay, any questions? Happy to answer them. Yeah, mate.
I've worked with TCL.
Sure.
One of the things that we know was always a problem with it is if you sent a large string,
yeah,
you could hang it.
Oh, yeah. Somebody you mean a very large string?
A very large string.
Yeah.
Use the get
yeah.
to pull it in. Yeah. Does coroutines help in any way in that aspect as well?
No, not unless you, there is a facility within TCL which enables you to avoid reading a string which will choke you. I think Don came up with it or told me about it. What's it? How much stuff there is in my buffer chan command.
Pending or something along those lines?
Yeah, pending, that's it. So you can avoid actually reading it by using chan pending, but it's completely orthogonal to the issue of coroutines. But there is a solution for it as well worth knowing about. I think that was thanks to George too. GBS hammered everybody and complained about it, and he was absolutely right, and so it was fixed. Any other questions?
Colin, did you explicitly mention the jQuery support in what?
Yeah, absolutely. jQuery itself, the jQuery, thank you, Steve. The jQuery user interface and about, 40 reasonably well supported packages are packaged in with what they do stuff like date entry, pop-up date entry. Let's see if I've got one here. Pop-up date entry and tabbed notebooks, accordion style. Here we go. I think right. Okay, so that's provided by jQuery. The beauty of it is all I need to do is emit a piece of HTML, give it the appropriate tag, and that all gets done for me. I should also mention that there are a whole bunch of utilities within WUB for formatting URLs, creating forms, processing queries, and just about anything else you need to do if you want to run a web server. But yes, thank you for that, Steve. jQuery is really good. Is that all? Anybody? Going once, twice. See you later.
Thank you, Colin. We'll have a short break and be back at 10 after 3, unless you want to extend the break due to the late start. No, be back at 10 after 3. Applications and Tickle and Tiki. Starting off is Keith Nash, presenting his paper with him and AJ Simons on tools for developing, distributing, and using Tickle and Tiki applications over the World Wide Web. Thank you, Keith.
Thank you.
Well, as Steve said, I'm going to be talking about the tools we use for using Tickle over the web. This is an outline of the talk. First of all, I'll start by talking about the general architecture, which is based on the Netscape plugin architecture of the Tickle plugin, and then talk about the web clients that we've developed on that basis, the data formats that we use, and then say a few words about the server side. Then just briefly mention the status of the project, where we're up to, and our conclusions. So first of all, on the web client, I expect a lot of you are familiar with the Netscape plugin architecture and the way that the Tickle browser plugin uses it. The top half of the slide is a block diagram of the parts of a browser process or processes. We have the browser here, and the other blocks down here are part of the plugin. The browser talks to the plugin by the Netscape plugin API, and for the Tickle plugin, it's in two parts. First of all, there's a part written in C that's a shared library, and then we have a part that's written in Tickle, which interfaces with the C part by its own API, which is a sort of Tickle analog of the Netscape API. That's the same thing without the annotations and a bit larger. This is how we use that architecture. Our aim is to replace the browser and the part of the plugin that's written in C with an application that's completely written in Tickle TK, and reuse the part of the plugin that's written in Tickle. And to go one step further, to split our application into two parts. One is the part that interfaces with the outside world through HTTP and with the plugin. And the second part interfaces with the bit I've just described. So we have a universal package that does the heavy lifting, talks to the Tickle part of the plugin and the web, and a GUI application that sits on top of that. And we've written 5 such GUI applications, and I'll go through them one at a time. Here they are. The first one we call the Curlin web client. The design goals for this are obviously to run TCL applets or Ticklets in a secure environment, and basically to resemble a web browser, a conventional web browser, as closely as possible, so that anyone who's used a tab browser can pick up how to use this client very quickly. The next thing we want it to do is, as well as Ticklets, we want it to be able to display data, and we're not going overboard on this. It's just simple things that we need, like directory listings, instructions, help files, etc. And we need it to integrate with the editor, which I'll describe later. So this is what it looks like. Conventional looking browser with a back button, forward, reload, stop, and home page. These are a bit less obvious. That one's create a new tab, and this one is open a sidebar, which we'll come to see in a minute. We've got 4 tabs open at the moment. This one gives us a directory listing. This one is a simple Ticklet, where you just click on the button to close the application. This one I'm sure a lot of you will recognize from the demo Ticklets on the plugin page, the Bezier clock. And this one here is possibly the best loved Ticklet of all time, Jeff's Tetris application. Now, clearly this one is a bit too big for the window. Now, obviously, we could increase the size of the browser window, but instead we can click on the button that opens the sidebar, and then we see we've got a number of options. One of them is to run the Ticklet in its own window. And what happens if we click that? is that the tab is unmapped and the container for the Ticklet is remapped as a top level. The web desktop, that's got similar goals to the web client, except that instead of looking like a browser, we want it to look like a desktop window manager. So the idea here is that anyone who's used, say, Windows from Windows 95 onwards would very quickly be able to get the hang of the web desktop. That's what it looks like when it opens as an application window. We can run it in full screen mode if we want to. And we have a start menu in the bottom left. When we click on the button, a menu appears. We can select any of the items, and then a window opens on the desktop. Now, the desktop is actually a canvas, and the window that we see here is a frame that's embedded on the canvas, and inside that we have a menu button, other buttons, and labels all the way round, and most importantly, a container frame that holds the Ticklet itself. We also have a taskbar, and if we right-click on the taskbar button, then we get the usual options that people will be familiar with. And there are three well-known Ticklets running in the window. The editor, this is a slightly more complicated beast, and it's got several design goals. First of all, obviously, we need to edit Tickle code. We also would like to execute it in place, and we'd like to edit and view documentation as well, and combine documentation and code in what we call a meta-source document, a worksheet. Load and save both Ticklets and worksheets to disk or web storage. And we'd like the worksheets to be to have the capabilities of holding tutorials, so that we not only use the web editor for editing the files in the project itself, but also we want to be able to use them, use the web editor as a platform for the tutorials. This is going back to the web client, the Hello World Ticklet. Now again, if we click on the button to open the sidebar, there's an option there which is View Source. And when we click on that, we bring up the editor, and we see we have the code in one box. This is a text widget. We have another text widget here with some rich text documentation. We can have as many text widgets as we like. If we put the cursor into this text widget and then press Shift Return, then the code is executed. With the upper box, if we double-click on the handle on the right-hand side, then we see that the box was folded. There's another box there that was hidden before, and that's the source code for this rich text. And so we can edit that source, press Shift Return, and then the lower box is re-rendered, and then double-click on the handle again to hide the source. I won't say too much about this one. This one is still in development. Its goal is similar to the web desktop, to be a simple window manager, but this time for displays that are rather small, something like a mobile phone. And this sort of front page is obviously quite polished, but the GUI itself needs some extra work. For example, when we click on one of these icons, what we get is simply a black rectangle for a while, because there's too much stuff going on in the background. And it's interesting how much psychology is involved, because when using one of the other applications, you have a GUI window to look at, and you don't notice the sort of 5 seconds while the application is loading. In this case, when you have a black rectangle, you do notice. And there's another application that, again, needs a little bit more polish. That's what I'll describe now. So again, this works, but there are issues with the speed and the rendering when the ticket is delivered. So the idea of this one is that we use it in exactly the same way as Wish, except that it loads the script into a secure environment. And it's also web-enabled, so we can load a ticket directly from the web. We've heard quite a bit at this conference and in the tutorials about making GUIs look how they should, look more attractive and blend in with the native style of the desktop. Most of that work is through applying themed widgets in the TTK namespace, but the widgets that we use most of all are the text widget and menus that we don't have themed alternatives for, and so we had to do a bit of work to make those look more attractive. But the text widget has a few oddities in its bindings. So, for example, here's a text widget with 3 lines. If we double-click on the empty space beyond here, what gets highlighted? And that really is empty space. There's a carriage return there. And I'm sure a lot of you will know what gets highlighted is white space, punctuation, and empty space, because the text widget only distinguishes between word characters and non-word characters that include both punctuation and white space. And there are similar, there are a few things like that, maybe half a dozen things that become quite annoying after a while if you use the text widget as an editor. And delving into the problem, we found that the text widget itself, the binary widget, is perfectly sound. There are just a few issues with the bindings that are provided by this file. And once again, I mean, this file, it's not the kind of thing that you wish to write from scratch, because really it's a magnificent piece of work. It provides around 100 bindings under 3 different windowing systems, and most of those are perfectly good. There's only a few of them that need to be tweaked here and there to so that what they do corresponds to what users expect on a modern desktop. And that work is now included in the package called ntext, which is part of TKlib. It's very easy to use, just package require it, and then when you create a text widget, set its bind tags to include ntext rather than the default text. Menus, that's another thing. When we post a menu and move the pointer over it, at least on X11, which I use, what we find is that the item that's under the pointer changes its relief, and most windowing systems don't do that anymore. What we really want is to change the background colour, and that's quite easy to do. It's only 2 lines of code. Similarly, once a menu is posted, in TK, if you want to move the pointer and move it sideways to an adjacent menu or into a sub-menu, on native applications, you don't need to hold the mouse button down, but on TK you do. But that's easily changed by just changing a few lines in menu.tcl. The data formats that we use, as well as the ticklets themselves, we need to provide rich text for data, help pages and directory listings, and a format for the editor worksheets themselves. And the format that we use is the one that TCL can pass most easily. And you get a clue from the name, because the dodecalogical refers to the 12 rules that define valid TCL. Specifically, executable dodecalogical markup language is defined to be a data format that is processed by execution in a TCL interpreter. For Ticlet code, obviously, it's the full, safe TCL language. For data formats, it's a little language where we've removed most of the commands, or all the traditional commands from the interpreter, and just put in the small number of commands that we need for our data format. And because the data comes from an untrusted source, obviously the interpreter has to be a safe one. Now, it's an idea that's been around for years and years, and certainly not my idea. It's probably been around since the beginning of Tcl itself. And I suppose you might be wondering why give it this elaborate name. But I think we don't really shout enough about the facilities that we have in Tcl, things that most language systems, most language communities can't do, and we tend to take them for granted. And I think if we're going to tell people about them, then at least we can give them a fancy name. So, when we're communicating between the web server and the client, we have 3 dialects of dodecalogical markup language. The first one, obviously, is for Tclits themselves. And we use a different MIME type from the conventional Tclits because we're likely to want to change the security policy. And it's not right to change the security, well, to have Tclits that were coded for one particular security policy and then try to run them in a different one. So we have a separate MIME type for that. The directory listings and rich text documentation are in this format, and that's a subset of the Notebook 2 markup. So it's a form of markup that can be rendered in a text widget. And really, we're indebted to William Duquette for that, and also for SNID, which is the object system that we use in these projects, which has really helped us to get things done a lot faster than we'd otherwise have been able to. The other format we have is for the worksheet data, the combination of code and text documentation. I won't say very much about the web server because it's not so much interest to a Tcl conference, but it's based on Postgres. We make use of transactions, which are really very useful for keeping metadata in sync. We use versioning so that old versions of code are never overwritten, and we have access controls so that we can have multiple users with private files in the database and different rights over public files. So we don't need an all-powerful sysadmin. Users are responsible for their own files. Sysadmin work can be shared and delegated quite easily because even sysadmins can't delete files. And most importantly, from the point of view of the system as a whole, we have a Tcl abstraction layer for the database. And I think if we were thinking of writing a web application in the conventional way, then I think there are so many technologies that one needs to get to grips with. Not only different flavors of HTML, cascading style sheets, JavaScript, differences between those things in different browsers, differences of implementation, bugs and so on. We've got Flash. On the server side, we've got multiple scripting languages, and those often come with middleware. We have usually a relational database as the back end, which uses SQL and a database programming language. And it's really quite a lot to get to grips with. Obviously, each layer has got to have its own API, but I can't think of a good reason why each one has to have its own programming language. Whereas if you're writing a Tcl-based web application, you only really need one language. You have Tcl, and you have the Tcl abstraction layer for the database itself. And so it's really a lot easier. Just say a few words about where we are. We've been hoping to have a public beta starting this week, but we're running about 4 weeks behind. There's a couple of things to do on the client side. We haven't got caching working. Now, obviously, that's useful so you don't download the same things over and over again. Also, so you can work offline. We haven't got user-friendly error handling in all cases. Sometimes we still get VG errors going to standard error. These things we don't need, so we won't be implementing them to begin with, even though they're part of HTTP. With the clients, we're still using the main, the standard plugin security policy, but I think in some cases it would be useful if we could make that a bit more flexible. So that, for instance, if somebody wants to download the Coccinella client as a ticklet, then obviously the purpose of that is to speak Java. And so when the thing tries to open a socket and connect to a Java server, it would be useful if a dialog comes up where the user has the ability to say yes or no to that, depending on whether they trust where the ticklet has come from. The editor, it started out really as an experiment and without a clear target in mind, and so it's the part of the project that needs the most attention for cleaning it up and bringing the coding into line with standards. Also, we have a couple of bugs. We have a large scrolled frame with all the text widgets in, and we run into the problem that the maximum dimensions for any widget in Tcl are 32K. So we need to work around that by mapping and unmapping widgets as they come into view. We also have a pernicious bug where when we write into a text widget, then even though it doesn't, the final dimensions don't exceed 32K pixels, at some point during the writing process they do, and that can bring the editor down. We haven't quite got to the bottom of that one yet. But on the positive side, the three main components, the web client, the web desktop, and the editor, they're all finished and in daily use. And so we have this library that's suitable for the main web protocols and file protocol. And we have these GUI applications and a server system that provides a multi-user data store and so on. A couple of things we'd like to add in the future. We'd like to have more choice of data formats in the editor. Basically, anything that can take plain text and turn it into something interesting. So MindTech is a good example. It's a system that has a Tcl-friendly extension that can take a plain text file and render it into an image using a subset of tech. GraphViz is the tool from Bell Labs that will draw nice directed graphs and so on. Simply displaying images in the editor would be handy. If we're ambitious, we could try and shoehorn Tcl doc tools into that format. We'd like to do some work on the policy, try and adapt the policy so that we can protect user files that are held on the web, because clearly the plugin policies are very good for protecting files on your own machine. That's one of the things they were defined for. But now that we want to have files on a web server somewhere, maybe the same web server that we're running an applet from. So if we had, say, a text editor and its data was on the same server, we want to be able to protect that from being hosed by random other applets. And we'd like to also evaluate commands not just in Tcl but in other servers. Maxima is one that springs to mind because that's quite Tcl friendly. It already has a Tcl front end, and it would be nice to have the extra flexibility of running it in KWE. On the server side, the back end is quite flexible, and we'd like to use that for purposes other than managing source code. Any kind of website, wikis, blogs, bookmarking, and so on. And we'd particularly like to make more use of safe interpreters on the server. Now this thing, AJAX, asynchronous JavaScript and XML, for us it's just asynchronous Tcl and Tcl, so it's ATAT. And when you look at it for a little while, you realise it's no big deal. It's just a remote procedure call. I mean, the reason I think why there's such an industry based around AJAX is that it's something you don't expect to find on a web page with JavaScript, and then suddenly one day someone discovered, oh yes, this JavaScript API was written and nobody's been using it. What can we do with it? And of course, because it was novel, it spawned a whole industry. There's a few pieces that are missing, and I think these remarks apply to Tcl in general. Obviously, Tcl's used in a lot of places, and they're mostly places that we can't see. They're not usually polished applications that you can run on the desktop. There are lots and lots of small Tcl applications. You can find probably hundreds of them on the wiki, little tools, toys and games. And we have a few desktop applications that are extremely high quality, like Coccinella. But really, we'd like a lot more of those. And if you look around the wiki, you find there are loads and loads of half-finished applications that have been abandoned. That, you know, they say latest release 3.2 Alpha 1, and you go to the website and you find, yes, latest release 3.2 Alpha 1, 1999, and you know, it would be nice if we had a toolkit full of applications that were as high quality as Coccinella. And I hope that this system will encourage people to develop applications like that, because I think really Tcl is the ideal platform for the deployment of rich internet applications and for the collaborative development, because when you get the Tclit, you get the source code. So as long as you get it with a suitable license, you can edit it, you can make your own Tclit out of it. And what you can do with Perlin is upload it back to the server so that other people can do the same. And so I think actually in many ways, the facilities that we've got in Tcl, and we've had for many years, more than a decade,